First, let us see what a tag is. A tag is just a simple way of labeling the AWS resources such that they can be easily managed, searched for, and filtered easily. Tag basically includes a key value pair. Tagging is not just limited to S3. It is a global concept across Amazon Web Services. It is applicable to many different resources such as EC2 instances or database instances, etc. For example, if your account consists of, let's say, 500 buckets and 200 EC2 instances across different departments such as software development, finance, travel, HR, and marketing, instead of just relying on their names, if a tag such as a department name is added to each instance or each resource, it will be easy to identify which buckets and EC2 instances belong to each department. Now let us see what is transfer acceleration about. Amazon S3 transfer acceleration, as the name suggests, enables fast, easy, and secure transfer of files over long distances between your client and an S3 bucket. So it can upload the objects over long distances in an accelerated, speedy manner. Whereas in multi-part upload, you can upload large objects in parts for fast and efficient data transfer. Tags are very useful for different purposes. First, tags are a great way to organize AWS resources in the AWS Management Console. You can configure tags to be displayed with resources and can search and filter by tag name. It also helps in cost allocation. This is one of the most important use cases for tags. AWS Cost Explorer and detailed billing reports support the ability to break down AWS costs by tag. For example, you may create a report such that you will get the cumulative costs of the resources grouped by each department. So resources or service specific tags are often used to filter resources during infrastructure automation activities. For example, you may tag EC2 instances as development or testing and production. And then you may automate it in such a way that during the non-working hours, all development instances would be shut down and back to running during the working hours. In access control, the IAM policies support tag-based conditions, hence enabling customers to constrain IAM permissions based on specific tags or tag values. For example, you can create IAM user or role permissions that can include conditions to limit, let's say, EC2 API calls to specific environments such as development, test, or production environment. And finally, a side note on tag set. A tag set basically contains all of the tags that are assigned to that particular bucket. A tag set can contain as many as 10 tags or it can be empty. The keys, however, must be unique within a tag set, but the values in a tag set don't have to be unique. So you may have keys that will have similar values, but the key names themselves should be unique. You can read further on this at this particular web page. Let us see how tags are created in AWS console. Here we are in the AWS console and on S3's homepage. Click on our bucket, go to its properties, and click on tags. As I mentioned before, tags are nothing but just a pair of key and values, so keep on adding tags for your bucket as you wish. For me, I'm going to add a name tag and I'm going to give a value AWS course. You can keep adding the tag as you wish. And that's it. You have successfully created 3 tags for your bucket. Now, why to even use the Amazon S3 transfer acceleration? As I mentioned earlier, S3 transfer acceleration improves the speed of the data transfer from your origin to the destination and vice versa. So you might want to use transfer acceleration on a bucket for various reasons. Let's say you have customers that upload to a centralized bucket from all over the world, or you have to transfer gigabytes to terabytes of data on a regular basis across continents, or you are currently underutilizing the available bandwidth over the internet when uploading to S3. The S3 transfer acceleration utilizes your available bandwidth in such a way that all your objects are transferred in a speedy and most efficient way. So let us see how S3 transfer acceleration works. S3 transfer acceleration uses CloudFront's distributed edge locations. We are going to learn about CloudFront in detail later, but let me quickly show how it works. AWS has deliberately constructed a network of high-capacity servers across the globe, which they call as edge locations. These are denoted by the yellow circles on this map. These servers use infrastructure of direct lines as well as fast mode of data transfer between them. Their job is to distribute the content from an origin to the destination that is several miles apart as fast as possible. However, they can also be used to send the data back to origin in an expedited or accelerated way. This is what is called as transfer acceleration, where the data goes back to origin, which is an S3 bucket, from the destination that is thousands of miles away. You can also use the Amazon S3 transfer acceleration speed comparison tool, which is located at this address, to compare accelerated and non-accelerated upload speeds across Amazon S3 regions. Here, you will have to wait a minute or two to get all the results. This tool uses multi-part uploads to transfer a file from your browser to various Amazon S3 regions with and without using transfer acceleration. The multi-part upload basically enables you to upload large objects in parts. We are going to see this in just a few minutes. S3 transfer acceleration compares the speed results and shows the percentage difference for every region. In general, the further away you are from the Amazon S3 region, the higher the speed improvement you can expect from using the Amazon S3 transfer acceleration. If you see similar speed results with and without the acceleration, your upload bandwidth or a system constraint might be limiting your speed. If you scroll down on this page a little, you can notice that for the region of San Francisco, that is US West 1, S3 accelerated transfer upload speed is 21% faster than that of the direct upload speed. However, for Tokyo region, it is 1% slower than the corresponding direct upload speed. For Sao Paulo, it is even 7% slow. However, for Mumbai region, it is 10% faster. So depending on your region, the speed of accelerated transfer and direct upload is going to vary. And based on these results, you can take a decision whether you want to go with the accelerated transfer or just go with the direct upload. Finally, it is the acceleration, additional data transfer charges may apply. So it is a costly option and needs to be selected very carefully. Now let us look at some of the important points regarding multi-part upload. The multi-part upload API enables you to upload large objects in parts. You can use this API to upload large objects or make a copy of an existing object as well. Amazon Web Services recommends that if your object size is 100 MB or larger, you should consider using multi-part uploads instead of uploading the object directly in a single operation. Multi-part upload occurs in three steps: initiation, upload of parts, and completion or abort. That is the third stage. Let us see how it works. First, user sends a request to initiate the multi-part upload to Amazon S3. S3 then returns an upload ID which is unique to that user's multi-part upload. Then in the second stage, along with that upload ID, the user specifies the part numbers to upload, which could be between 1 and 10,000. The part numbers could also be random. Then Amazon S3 returns an e-tag header in its response. For each part upload, the user must record the part number and the e-tag value. The user then need to include these values in the subsequent request to complete the multi-part upload. So at this stage, user will be uploading multiple parts along with the part number as well as the previous e-tag. Finally, in the last stage, the user has to either complete or abort the upload. Once the user completes the upload, S3 creates an object by concatenating the parts in ascending order based on the part numbers. If you want to deep dive into how internally multipart upload works, you can visit the site given below. But for the exam point of view, it is sufficient to know this much about the multipart upload. In this video, we learned about what tags are and why they should be used. It is a very simple yet very important concept. Tagging of resources is important for architecting a good solution on AWS and certainly very important from exams and further professional level certifications point of view. We also learned about S3 transfer acceleration, and in that we learned that it leverages CloudFront's globally distributed edge locations and multi-part upload for accelerated transfer of the data. Finally, we learned about multi-part upload functionality provided by Amazon S3. It enables you to upload large objects in parts for faster and efficient data transfer. I hope you guys understood these concepts. They are easy but very important for the exams. Thank you for watching this video. I will see you in the next one. Thank you. Hello again. In this video, we are going to learn about S3 event notifications. This is a very interesting topic. So what is an S3 event? It basically allows you to send notifications when certain events happen in your bucket. For example, when a user uploads an object to a bucket or updates it or deletes it, you can get notified about it. So how does the user get notified? Well, you can either send an email or text notification via SNS topic, publish the event to SQS queue, or run some code in response to the event via AWS Lambda functions. I am going to demonstrate S3 events by using SNS or Simple Notification Service topic. For that, we will have to do some initial setup. But before that, let's quickly see how SNS works. First, you create a SNS topic, which is like a communication center or channel to which the publisher or the originator of the message sends a message. Then you configure the receivers or subscribers who receives the message whenever it gets published. In our case, S3 service will be the publisher of the message and will configure an email ID that will receive the message after publishing. Let us now configure our SNS topic and the subscriber. For that, you will have to log in into the AWS console. In the AWS console, first go to SNS, which should be under Application Integration. You have to make sure that you are selecting the same region in which you have created your bucket. For me, it was Ohio. So I'm going to change the region to Ohio. Click on Get Started. We need to create a topic. So click on Create Topic. Let's call our topic as Object Added Deleted Topic. Give a display name. Now note here that you cannot exceed more than 10 characters. So you will have to be brief here. I'm going to call it obj add del. Click Create Topic. Currently, we do not have any subscribers. So let's create a subscription. We are going to use email as the protocol. This endpoint is going to be the user's email ID. Use the one which you can access and click on Create Subscription. Once you do that, you should get an email notification asking you to confirm the subscription. Go ahead and confirm it. Then you should get this message. Back to SNS, if you refresh, the subscription should be set, and whenever a service will send a message to this topic, you should get an email about it. Currently, this topic will only allow the logged in user, that is this particular account, to be the publisher as well as the subscriber. We need to change this such that S3 can publish a message to this topic. So go to Other Topic Actions and select Edit Topic Policy. Select everyone to allow them to publish messages to this topic, and also select everyone to subscribe to this topic. Click on Update Policy. Now before we go to S3, copy this topic ARN. Go to S3. Click on the bucket. Go to Properties. Select Events. Add a notification. We are going to give it a name as object added and deleted. Now let us configure this bucket such that whenever anybody uploads an object to this bucket or deletes an object from this bucket, a notification will be sent. So select put, post and delete as the events. Prefix here basically means that it will notify about only those objects whose key start with this prefix. Let us keep it empty. Suffix, let us keep that empty as well. As I mentioned before, you can either send a text notification via SNS topic, publish the event to SQS queue, or run some code in response to the event via Lambda function. SNS, that is simple notification service, SQS, that is simple queue service, and AWS Lambda, these are AWS services with different offerings and domain of expertise. We will be having a separate video on each of them, but for now, we will publish the event via SNS topic. Select the topic that we just created. Alternatively, you can also add the SNS topic ARN, which we just copied. You can just paste it here, or just go ahead and simply select the topic that we created and hit save. And there you go. You have successfully created this event notification. Henceforth, whenever someone adds an object to this bucket or deletes any object from it, it should raise this event and you should get an email notification. Let's try that. Let us go back to our bucket and add an object to it. Now within few seconds, you should be getting an email indicating that an object was added to this bucket. So go ahead and check your inbox. You should have received an email with the subject name as obj add del, which looks like this. If you look at the content of this email, you can find the information about a record which contains event version, event source, which was S3, the AWS region, that was US East 2 or the Ohio region, the event time, that is when the event occurred, that is when the object was uploaded, and so on. It also contains the information about the bucket, that is the bucket name, the owner identity, the principal ID, ARN of this bucket, the object name, its size, and so on. Now let us go ahead and try to delete this object and let's see if we get notified about it. So go ahead and right click on this object and say delete. Once the object is deleted, within few seconds, you should get another email with the same subject, that is obj add del, indicating that the object was deleted. And you can verify that by looking at the object removed property with the value of delete. In this video, we learned about how S3 event allows you to send notifications when certain events happen in your bucket. We saw an example where we uploaded an object to a bucket and then deleted that object from that bucket. We got an email indicating the both actions were done on your bucket. For the notification, you can either use an SNS topic, you can publish the event to an SQS queue, or run some code in response to the event via AWS Lambda function. Thank you for watching this video and I will see you in the next one.